So 9.1 was all about points, lines, angles, planes, that kind of stuff. Now we're going to close up our shapes, and we're going to have curves, polygons, circles, and it says and geometric constructions. I actually kind of cut that bit out, mostly for time purposes, and just knowing what you guys will and won't see later on. So we have to talk about simple curves and closed curves. Again, lots of definitions, but I think the pictures help really make it kind of a logical conclusion on these. So a simple curve can be drawn without lifting your pencil from the paper, without passing through any point twice. So simple curves can be drawn simply by putting your pen down and doing a squiggle. That's a simple curve. It's kind of weird, but it works. What's not a simple curve is that, because we cross it. We can't cross it. To be simple means you have to be simple. No crossing. A closed curve has its starting and ending points at the same point and is drawn without lifting your pencil. So to be closed, you are simple. Like this is a closed one. We went from here and we ended there. This one is not closed. My starting point and my ending point were totally different. You can also have things that are not simple and not closed. This one's neither, because it crosses, thus it's not simple, and these 2 points are not the same, my starting and ending point, thus it's not a closed curve. So I know some of your assignments for 9.2, they're going to give you some squiggles, and they're going to ask you, is it simple? Well, the question is, can you draw it without picking up your pencil? If you can draw it without picking up your pencil and you don't cross, then it's simple. And then that'll ask you, are you a closed curve or a closed surface? Well, if where you start is where you end, then yes. So simple curves, closed curves. Questions? After simple and closed, we can talk about convex and not convex. Now, convex, we oftentimes pair convex with concave when we think about it in the real world, when we think about how something is shaped and like whether it holds water or whether or not it makes a dome. In this class, in the geometry section, it's a little bit different. A convex shape or a convex figure is a simple, closed figure where for any 2 points that live inside the figure, you can draw a line segment connecting those 2 points that will also be completely inside the figure. That means you're convex. So it has nothing to do with whether or not you can hold water or you dump water or any of that kind of stuff like we think of in terms of 3D shapes. These are 2D shapes or figures. And so convex simply means there's A and B in here, and I can connect them, and my line segment lives in here. And I can do this for any A or B that live inside my convex shape. Your non-convex shapes are where you can have an A and a B, and you can connect them, and part of your line segment ends up outside of the shape entirely. Now, I could move my B, and I could make AB live into that shape, but the point is that I can make this happen. And if I can make this happen, it is not convex. We don't call it concave because that's a totally different concept. Convex and concave in terms of that is dealing with 3D shapes, not simple figures like we're talking here. So it's just convex or not convex. Usually if there's a big like gap or valley or something like that in your shape, that's a good idea. That's probably not convex. Here's a couple. Oh, there's some more coming up. We have some polygons that are convex or not convex. A polygon is a simple closed curve made up of only straight lines. So there's no rounded sides. Everything's got a straight line. I could draw any of these shapes, whether convex or not convex, by putting my pencil down and tracing them, and I would never have to pick it up. My starting point and my ending point, they're all enclosed. I could color it in if I wanted to. So these are all simple closed figures. But we also would call these polygons. Poly means many, so they're many-sided shape. But these first three, that are a little bit lighter on the copy, these first three are convex. I could do the straight line through them, and the straight line would stay. These other two are not convex. I could have point A up here and point B down here. I could connect them, and it goes outside of my shape. Same thing with over here. Or even over here, I could connect it that way. And it would go outside of my shape. So these are not convex. We have another designation for regular polygons. These are the ones we usually like to play with. Regular polygons are polygons that all have the same side measures and angle measures. These are the quote-unquote nice ones. These are the ones that maybe back in a high school geometry class, if you had one, you had to do what's known as a tessellation, where you'd move those little plastic shapes across your paper to repeat a pattern. Or you even made some 3D, like dodecahedrons, or things like isohedrons, and I'm trying to think of some other names of them. Basically, you made soccer ball-looking shapes. Those are made out of regular polygons. You can't make a soccer ball out of just any polygon. They have to all have the same side lengths, or your ball's never going to get put together right. And so regular polygons are the nice ones. All the sides of this triangle have the same measure, or all the sides of my hexagon have the same measure, and thus all the inside angles would have the same measure. Okay, we're going to flip over. We're going to do the back side and call it good for part 1 of 9.2. There's nothing for you to do here. We're going to talk through some stuff, and it'll help prep us for part 2 next time. Now, do not feel like you have to start memorizing all of these different sided names and stuff. They do list the top 10 or number of sides from 3 to 10 of your quadrilaterals or of your polygons, simply because these are the ones that will get brought up the most often. And most of these you probably already know. There's triangle, which is 3-sided. Tri, T-R-I, think of tricycle, has 3 wheels. Triangle has 3 angles. Quad, that's 4. Quadrilaterals have 4. There's a lot of different quadrilaterals. There's actually, that's what this table is down here. There's trapezoids, polygons, or parallelograms, rectangles, rhombus, a square. Those are all different types of 4-sided figures. So all of these would be known as a quadrilateral, even though they're all slightly different from each other. Pentagon, penta means 5. Hexagon, hexa means 6. Hepta means 7. Octagon, that's your stop sign, 8. Nonogram is 9, and decagon is a 10. So if you ever had Latin, then that's where a lot of these words will come from. A pentagram is a 4-sided or a 5-sided star. There's other things that get. The octagon, besides the stop sign, is also the shape of the MMA fighting, right? Yeah. So you do see it in a couple other places as well. A big one for 9.3 is going to be understanding the different types of triangles. Just like we have this huge table of different types of quadrilaterals, we spend a lot of time with our triangles. And there's lots of different ones, just like there was lots of different angles that we talked about in 9.1. We had acute angles, we had right angles, we had obtuse angles. We can also have acute triangles, right triangles, and obtuse triangles. So acute triangles, all the angles are going to be acute. All of them. It's all or nothing if you're acute. If you are a right triangle, one of your angles is a right angle. And it will always have that square designated there for where the right angle is. Your other 2 angles are acute, if you want to know that. If you are an obtuse triangle, you have 1 obtuse angle. the other two angles are acute. So every triangle is going to have some acute angles, but if you're an acute triangle, it's all. So that deals with their angles. But we can go even further and talk about their side lengths. And we have to have this information later in order to prove that triangles are the same, or that they're congruent, or that they're similar. So when we're looking at the sides of triangles, we can have what's known as an equilateral triangle. Notice the little tick marks. Those tick marks are there to tell you that all those sides have the same length. They all have the same measure. And that's kind of alluded to here with equals. They all have equal sides. Isosceles triangles are where you have two sides that are the same. And notice this third side has two tick marks in it because that one's different. It doesn't equal the other two. So isosceles has two sides that are the same. And the last one is known as scalene. Notice all the sides have different numbers of tick marks, 1, 2, and 3, and that's because none of the sides have an equal measure. You will encounter all of these as we progress throughout this class. We use these a ton in 9.3, and even just in the second half of 9.2. So that's why I included the table. I think the tables are nice, but there is little hints, like I said, like equilateral will help you know that every side is the same. Just a quick overview. I know I mentioned that these are all different types of quadrilaterals. I'm not going to read everything that's special about them, but there is something that's a little bit unique about your quadrilaterals in that if you start at the bottom with your square, this is a quadrilateral. Notice all the sides have the same measure. All your angles are the same measure. Well, a rhombus is a parallelogram where all the sides are the same. If you are a square, you are also a rhombus. You're just a special kind of rhombus. If you are a square, you are a rectangle. We don't like to say that because usually when we say rectangle, we know we are going to have two long sides and two short sides. But by definition, a rectangle is just a parallelogram with right angles for all of its corners. That's what a square is. And so if you start at the bottom, a square is a rhombus, is a rectangle. It is also a parallelogram because a parallelogram is a quadrilateral with two pairs of parallel sides. These two sides run parallel and the top and bottom run parallel. Well, my left and right sides run parallel to my top and bottom sides. So a square is also a parallelogram. Trapezoid is kind of a unique one. We wouldn't classify a square as a trapezoid simply because in general, if we say the word trapezoid, we have these two sides that come down going opposite directions on it. It's like we chopped a hexagon in half is what we do with a trapezoid. But we can actually classify a lot of our different shapes as each other, just depends on what we're talking about. All of these, though, are quadrilaterals. They're four-sided polygons. And so you will have to do some designating on those.